starting Unit 4 today, and that's counting methods. And we're looking at 4.1 today, counting principles, which is pages 228 to 237. Our curriculum outcome is 30.6 to demonstrate understanding of combinatorics, including the fundamental counting principle, permutations, and combinations. Our lesson objectives, number 1, to be able to state the fundamental counting principle, and number 2, to be able to apply that fundamental counting principle to various questions. So we're going to start with an example. It says, imagine that you go on a trip and pack 4 pairs of pants and 5 t-shirts. How many different outfits could you wear? Well, with 4 pairs of pants, each pair of pants that you wear, you have an option of 5 t-shirts, so that means you have 20 options for outfits. And if you also pack 3 pairs of shoes, well, with those 20 options for outfits, you also now have another option of 3 different pairs of shoes, so now you're looking at 60 different outfits. And if you packed 5 hats, well, now you have 4 times 5 times 3 times 5 different hats, and that gives you 300 different options for outfits. So what we just use is this form of logic is actually a process called the fundamental counting principle, which states that if there are A ways to perform a task and B ways to perform another task, then there are A times B ways of performing both. You just have to multiply those things together. If you need to, it might be easier for you to use a series of blanks when you're going to answer these questions, one for each decision that you have to make, and then you can fill in your blanks with your number of options for each decision. So as we had here, we would have had 4 different blanks. One for our pants. Next one is for our shirts. Our next one is for our shoes, and our last one is for our hats. And then we just fill in the number of options that we have for each of those decisions. So here's our first example. It says, how many different ways are there to create a postal code in Saskatchewan if the first letter has to be an S? So we know that for postal codes, I hope you know this, that it goes letter, number, letter, and then there's a space, and then number, letter, number. So it looks like we have 6 different blanks that we need to fill, but it says the first letter has to be an S. So if we're going to draw those 6 blanks and start filling them in, here we only have one option. It has to be the letter S. Now, this number here, there are 10 different digits. If you go from 0 to 10, or 0 to 9, sorry, there's 10 different digits. And you need to know that there are 26 letters in the alphabet. This one could be any digit again, this one could be any letter, and this one could be any digit. So in the end, you just have to multiply those numbers together. So 10 times 26 times 10 times 26 times 10. And you end up with 676,000 different options or arrangements for a postal code in Saskatchewan. Our second example says a rotating bike lock opens with a 5-digit code by rotating the wheels through the digits 0 to 9. Which lock would be more secure? A lock that allows repeating digits or a lock that does not? So let's talk about, we're going to have 2 different options here. Option number 1, if we can repeat digits. So there's a 5-digit code, it means we have 5 blanks to fill. And it says what's going to be more secure, lock that allows repeating digits. So if we did this one as repeating, that means that this could be a 1, 1, 1, 1, 1, or a 2, 2, 2, 2, 2, or it could be any number of options with each of those numbers, each of those digits. So that means we have 10 across the board because we can repeat. And that means with repeating, there are 100,000 different lock combinations. Now, the next part is if we had 5, we still have a 5-digit code, and we are not allowed to repeat. So once we use a digit, we can't use it again. So if we had an option of 10 digits in our first space, then we don't have 10 options anymore. We only have 9 for the second space. Now for the third space, we can't use that one or that one because it says we can't repeat it all. So that would be 8, and then 7, and then 6. And our answer there would be 30,240. So if you want a lock that's more secure, you'll want to get one that you can repeat numbers with, because you have 100,000 different lock combinations as opposed to 30,240 different combinations. And our final example says, if you were to draw a single card out of a deck of cards, how many different ways are there to draw a club or a face card? And the part B says a red card and a 2. So once you see these keywords, this or and this and, you might want to start thinking about what we did last unit when we had to use Venn diagrams, or just some way to organize your information. So we're talking about a club or a face card. So if we had, for part A, if we had our Venn diagram, And we had clubs over here, and we had face cards over here. And we're looking for or. So we hopefully remember that or means it could be either in C or in F or in the middle. And so the number of clubs in a deck of cards is 13. However, 3 of those are face cards. That means the number of cards that are just clubs are 10. And 3 of those happen to be face cards. So they'll remember that this little area in here is and the second part is face cards. We know that there are 12 face cards. There's a jack, a queen, and a king for each suit. So that means 12 of them. But 3 of them are clubs, which means we have 9 left over. So if we want to find out how many ways we could draw out a club or a face card out of that deck of cards, that means we have 10 plus 3 plus 9, which gives us a total of 22 different ways to draw out a club or a face card. Now, part B, a little bit different, because it says a red card and a 2. So we could do the same thing. We could have red cards, and we could have 2s over here. And we should know, hopefully, that there are 2 suits that are red, diamonds and hearts, and each suit has 13 cards in it, which makes 26 red cards. But 2 of those red cards are going to be 2s as well. So this and part in here is going to be 2. And that would be the 2 of hearts and the 2 of diamonds. That means we have 24 over here. And we've already answered our question, I guess, because it says a red card and a 2. It means there's only going to be 2 answers. Although, if we want to complete the diagram, we also have 2 black cards that aren't red cards. So here's our total of 4 2s in the deck. So once again, a red card and a 2 card means we have 2 chances of drawing out a red 2 out of a deck of cards. So in summary, we know that the fundamental counting principle states that in order to find your number of possible arrangements, and that's a key word here, then you simply need to multiply all your options together. Now, in some cases, you'll need to use some thought, so it might not be as easy as you think, to determine how many decisions need to be made and how many options there are for each decision. We did an example where things could be repeated when things can't, so you might want to keep that in mind when you're going through these questions as well. And in some cases, with those keywords where we had or and, it might be necessary to use a Venn diagram to help organize your information, or any sort of other diagrams or things that you may have learned along the way that could help you organize that information so you could actually answer the question. So our assignment is on pages 235 to 237. Good luck, and we'll see you in class.